Okay, now we're going to go over section 10.5, which is area of regular polygons using trigonometry. So we're still using regular polygons. Everything we talked about in section 10.3 applies. And we're still using that 1/2 apothem times perimeter formula. The only new thing is instead of using 30, 60, 90 or 45, 45, 90, we're going to instead use trigonometry, the sine, cosine, and tangent. Remember we talked about in chapter 8 that it was going to be really important to get down that chapter 8 information because we're going to use it in chapter 10 and chapter 11. So if you need to review back over your notes or assignments from chapter 8, feel free to do that, but we're going to kind of review over that as we go here as well. So we talked about for trigonometry that SOHCAHTOA is a really good way to remember that. I usually prefer to stack them on top of each other like that, but writing it out this way is fine as well. Okay, so it's just a reminder that SOH stands for sine is equal to opposite over hypotenuse, that cosine, the CA, is cosine adjacent over hypotenuse, and the TOA stands for tangent is equal to opposite over adjacent. Again, when we're talking about opposite and adjacent, we are talking about the opposite leg or the adjacent leg. Okay, and the hypotenuse is what's across the right angle. So just as a little reminder there, you know, if this was angle A, then this side would be the opposite, you know, side. I'll go and put opposite. Okay, in reference to angle A, this would be the adjacent leg because it's the one right next to it, just like my room is adjacent or right next to Mr. Miracle's room. And then the hypotenuse is what's across from the right angle. So it's good to kind of keep in mind what all the pieces are to make sure you're using the right trig ratio to solve for the missing piece. We're still using the area of a regular polygon that we talked about yesterday, where it's 1/2 times apothem times perimeter. And again, just as a reminder of what those stand for, the A is the apothem. And again, the apothem is that right angle distance from the center out to one of the sides. And the P stands for the perimeter, which is the distance around a figure. And again, if you need to refer back to those notes from section 10.3, then feel free to do that because all of that applies to today as well. Okay, so let me go and get this moved up. All right, and here we go on example 1. So for example 1, it says, what is the area of a regular polygon with 10 centimeter sides? Or regular nonagon, I didn't read that correctly, nonagon, which means it has 9 sides. Again, that's either something you just know or you can count the sides. And it says round your answer to the nearest tenth this time. So you still want to leave it in exact form until the very end, and then you can round it to nearest tenth. You don't want to round and round throughout the problem. So in this particular case, I first want to get a triangle in here to deal with and also write down my formula. So I know that I'm going to end up using the area is equal to 1/2 apothem times perimeter formula. Okay, I just need to do some work before I can actually use that. So I'm going to kind of write that off to the side. All right, I'm going to go ahead and draw my triangle, and here's my center. And this time, I'm just going to draw one triangle. I guess this is the way I usually do it. Usually when I start off on section 10.3, I kind of show you drawing all the triangles, and then I kind of by 10.5, I'm just drawing one triangle just to save you time. If it helps you to draw all the triangles, feel free to do that. Okay, and then I got to think about how do I figure out what this angle is. So just like we were doing in section 10.3, I can go 360 divided by how many sides it has. And again, if it's a nonagon, I know that means 9 sides. So if I go 360 divided by 9, then I get 40. So I do know that this whole angle is 40, but I'm not going to write that in yet. I have to actually go 40 divided by 2, which is 20. And I also need to draw my apothem. Again, apothem forms a right angle with the side, and I now found that these two little angles are both 20. Okay, and this is 90, that's 20. If you want to go ahead and put 70 in here, feel free to do that. You don't have to do that. I know that I cannot use 30, 60, 90 or 45, 40 of 90 here because this is not a 30, 60, 90 triangle or a 45, 45, 90 triangle, and that's why I have to use the trig, okay? If I'm using trig, I can do it from either one of these acute angles and get the correct answer. It does not matter. So one person can use the 20, one person can use the 70, and they'd end up with the same answer as long as they set it up correctly, all right? So the way I chose to do it this time is I chose to use the 70, okay? Again, if you chose to use the 20, that is fine. So I have to realize my formula that I'm going to use here. I need to know the apothem that I don't know yet, and I need to find the perimeter, which I can find that pretty easily. I can see that each side is 10 centimeters, so I need to get that put in my picture. Okay, and if I know each side is 10, I can pretty quickly find the perimeter. Sometimes I like to go ahead and do that. If that part's the easy part, then I might go ahead and do that. I'm like, okay, perimeter is n times s. I know that there are 9 sides. I know that each side is 10. And so I'm going to go ahead and do that part because that's my quick, easy part. I know the perimeter's 90. I'm going to wait and plug in the formula in a minute, but at least I know that. Now I have to figure out what this apothem is, and sometimes people get confused since we're talking about adjacent and apothem and that kind of thing. They get kind of mixed up. So for right now, I'm going to say I need to find this apothem, but I'm just going to call it an x for right now so I don't get confused, okay? I also want to go ahead and show that if this whole thing is 10, I know that that is 5, and now I want to try to figure out if I'm going to use sine, cosine, or tangent. Okay, so here's a right triangle. I'm going in reference to this angle. You could use the 20 if you wanted to instead. But if I'm using this angle, this is opposite. So I'm going to put an O. I'll go ahead and put opposite. And this one is the adjacent leg. Okay, so I know that if I've got opposite and adjacent, again, if it's helpful to you to write this, I can see opposite and adjacent has to do with TOA. Okay, so I'm going to set up tangent. Remember, it's always sine, cosine, or tangent of the angle, and in this case your angle is 70, is equal to opposite over adjacent. I usually write that step first, and then now if I go and plug in for that, my opposite is my x, my adjacent is my 5. And then remember, when we're solving these, if I'm trying to find one of the side lengths, I'm going to cross multiply. If I'm trying to find the angle, I'm going to use my inverse sine, cosine, or tangent, my tangent to the -1. But in this case, I'm just going to put a 1 underneath this. Tangent of 70 is just a number. I can think of it as cross multiplying. So in this case, I've got 1 times x is x, and 5 times tangent of 70 gives me that. And so I know that that represents my apothem. Okay, I'm not going to make that a decimal yet because, again, I don't want to round throughout the problem. I'm just going to leave it like that for now. So if I come over here, I have what I need to plug in. My apothem I just found is 5 tangent 70. That represents a number. I'm going to plug that in. Perimeter I already said was 90. Just kind of make sure you're being really neat and clear with everything you're doing so you can find what you need. And now, if they wanted me to leave this answer in exact form, I would not multiply by the tangent 70 yet. I would just go 1/2 times 5 times 90. And if I go ahead and do that, I don't have that written down. If I go 0.5 times 5 times 90, I get 225. Tangent 70. That didn't show up wrong. 225 tangent 70. So if they ask for an exact form, that would be it. In this case, they want it to the nearest tenth though. And so if I go ahead and get that plugged in to the nearest tenth, I end up with 618.2. And that is centimeters squared. So that's the answer they were actually looking for here. Okay? All right, so just again, be neat and clear with your work. All right, let's go ahead and do example 2. And so for example 2, let's get that moved up. And this is going to be a pentagon this time. So for a pentagon, it says, what is the area of the regular pentagon with 4-inch sides? Round your answers to the nearest tenth. So again, so we're starting off the same way. We know that we're going to end up using our 1/2 apothem times perimeter formula. Okay, we don't have another option for that. We know that it told us that one side is 4, so I'm going to go ahead and show that. Okay, I know that I need to get my triangle drawn in here, so here's my center. I can do my triangle. Again, you can draw all the triangles if you want. I like to just focus on one. And if I want to find this angle, again, I know that I'm going to start off with 360 divided by this time 5 sides, and that gives me 72. Okay, so I know this whole angle is 72, but if I draw the apothem down the middle, it halves it, and then I get 36. So I'm going to go ahead and show that. There's my apothem. I know I've got 36 here and here. If you want to go ahead and find these angles, you can. Again, 90 plus 36, subtract that from 180, and you get 54. Again, you can choose to use either angle to work with this. I chose to work with this angle. Again, you know, if you kind of think about it, then sometimes one way is a little easier than the other, because you end up, when you're cross multiplying, you end up multiplying instead of dividing. So that can kind of make a difference in your decision, but it really doesn't matter. You'll end up with the same answer either way. Okay, so I just like to circle which one I'm using to help keep that straight. I also can see that if this whole length is 4, I know it's 2 from here to here. And I also know that I need to find the apothem using the trig. I'll do that in a minute. I also need to find the perimeter, and the perimeter is the kind of easy part. So I'm going to go ahead and get that taken care of. So if I go ahead and do perimeter is n times s, then I know there's 5 sides here. I know each side is 4. And so that gives me a length of 20. Yeah, the perimeter is 20. Okay, now I'm going to determine if I'm going to use my sine, cosine, or tangent. Again, I am looking for, I'm going to call this my apothem. I'm just going to make an X there so I don't confuse with the A. And again, I can see that the opposite and the adjacent leg are the two things that I'm dealing with. Okay, so again, if I write my SOHCAHTOA here, then again, opposite and adjacent have to do with TOA. So that means over here I'm using tangent. Again, just like we did on the last problem. Tangent of the angle, in this case 54, is equal to opposite over adjacent. So just like last time, I've got x over 2. Okay, again, when I'm looking for a side length, I'm going to cross multiply. So I can put a 1 underneath. Tangent of 54 is just a number. When I cross multiply, I've got 1 times x is x. And 2 times tangent of 54 is 2 tangent 54. And again, I'm not going to multiply that out yet. I want to leave that in exact form until the very end. So that's my 2 tangent of 54. So if I go up here, I can plug in what I know. Got my 1/2. My apothem that I just found is 2 tangent of 54. My perimeter I already found was 20. And if I go ahead and multiply that out and leave it in exact form first, 1/2 times 2 times 20 gives me 20 tangent of 54. Okay, but the directions say to round it to the nearest tenth. So if I go and plug that in my calculator to the nearest tenth, then I get 27.5, and that is inches squared. Okay, so that gives us the area of that pentagon. All right, one more. These just take a while. So on the last one, we are going to find the area of an octagon. And this one's a little more messy, but it's all right. You can do it. I'm going to go ahead and move it up so you're not going to be able to see the wording, but we'll get it labeled on our picture. Okay. So, in this one, if you read the directions, it says, what is the area of the octagon stop sign if the radius is 16.2 inches, round to the nearest tenth? So they're giving us something different this time, and we've got to make sure we pay attention to what they're giving us. So, I've got, find my center, this one's really huge. So I'll say that's my center. And I'm going to draw that radius and that radius. And the number that they're giving me here is they're giving me the radius. Remember, from the center out to one of the vertices is 16.2. Okay, they didn't give me the side length. They didn't give me the apothem. They gave me the radius. So it's very important that you label the right thing correctly. All right, if I think about what formula I'm going to need this time, then I am going to use this. I am going to use this 1/2 apothem times perimeter formula. But if I think about it, I don't know the apothem at this point, and I can't even find the perimeter pretty easily at this point yet because I don't even know a side length. So I need to start using my trig stuff first before I can even find the apothem or the perimeter. Okay, if I go ahead and draw my apothem down the middle. All right, and now if I go ahead and start thinking about my angles, okay, like we've done before, then I know that it's 360 all the way around here. Let me use some of the space up here so we don't run out of room. And it's an octagon, so there's 8 sides. So 360 divided by 8 gives me 45. So I know that this whole angle is 45, but if I just drew the apothem down the middle, I basically just halved that. Okay, so now I know that this is 22.5. I know that is 22.5. Okay? Then, if I want to go and find this angle, I can. Again, you don't have to, but you can. If I add these two up and subtract from 180, then I get 67.5 down here. Okay? And the way I chose to do it in my notes, and I'll do it the same way here, is I chose to use this angle again. All right? So the first thing that I chose to do was go ahead and try to figure out what the apothem is. Okay? So again, like we did on the last one, I'm going to call it X, so you don't get confused with adjacent, with them both having an A. All right? And in this case, I know that if I'm using this as my angle, this X length is opposite. And I know that this length that I know, 16.2, is across the right angle, so that's my hypotenuse. So if I think of my SOHCAHTOA, okay, if I've got O and H, then this time I'm dealing with sine. Okay, so a little different than last time. So I'm going to go ahead and put that right here. So I've got sine of my angle, 67.5, is equal to opposite over hypotenuse. So my opposite is my X, and my hypotenuse is my 16.2. And again, I am going to cross multiply like we did before. And when I do that, I get 1 times X is X, and 16.2 sine of 67.5, and that is representing my apothem. If it helps you to label that. Okay. Now I also need to find out what this length is from here to here. Okay, so I will call that Y this time, just so we can kind of keep straight what we're doing. Okay, so if I do that, then this length is adjacent to this. Remember, it's right next to, so I'm going to call it the adjacent. And this is something that I was given at the beginning, so I'd rather use that number than this number. So that's my hypotenuse. If I'm dealing with adjacent and hypotenuse, then I'm going to use this one, cosine. Okay, so here we'll switch colors for that. So if I'm using cosine, I'm going to go cosine of 67.5 is equal to adjacent over hypotenuse. So my adjacent is my y, my hypotenuse is my 16.2, and if I want to cross multiply, I can do that. So 1 times y is y, 16.2 cosine of 67.5 gives me the length from here to here. Okay, but be really careful. If I want to find the perimeter, I need to know what this whole length is from here to here. So think, what do I do to this to get the whole length across? I have to double it. So to get one side length, I have to go 2 times 16.2 cosine of 67.5, and that gives me 32.4 cosine 67.5. Okay. So now that is my side length, but I still need to find my perimeter, right? So I'm going to do that out to, where am I going to do that? I am going to do that out to the side here. So my perimeter is then n times s, where I know that it's an octagon, so it has 8 sides. And one side length, we just said, is 32.4 cosine 67.5. And if I go ahead and multiply that, again, keeping it in exact form, then I'm getting that my perimeter is 259.2, and then cosine of 67.5. And that is my perimeter. So now I know my perimeter, okay, which is right here. My apothem I already found up here, and now I can finally use this formula and plug in what I know. I'm going to do it down here at the bottom, and you know, this is where I'm using this. I'm not going to rewrite it again. I'll just kind of point to what I'm doing. So I've got 1/2. My apothem, I said, was 16.2 sine of 67.5. And my perimeter, I just came up with, was 259.2 cosine 67.5. And if I go ahead and get that multiplied, then I went ahead and put all this on my calculator. I went and did 0.5 times 16.2 sine of 67.5. You might want to hit equals unless you put in some parentheses there, and then multiply times all this and rounded to the nearest tenth. I guess let me write it in exact form first. I'm going to go and write it in exact form first just in case you ever asked for that. If I did 0.5 times 16.2 times 259.2, then I would get 2099.52, but then I still have my sine 67.5 and I have my cosine 67.5. Okay? If I'm going to put that in my calculator, I've already got my 2099.52 in my calculator, so if I go times sine of 67.5, okay, again, at this point, you can either close the parenthesis and then do times cosine 67.5, or you can go ahead and hit equals here, and then go times cosine of 67.5 equals. And then if you round that to the nearest tenth, you get 742.3. And then my units on this one is inches, so I'm going to say inches squared. All right, so that was a fun one, huh? Nice and long, but you can do it. They're not always going to be that bad, but again, if you just kind of keep straight what you're doing, then you'll be good. Nice thing about these homework assignments is there are not too many questions on these. Again, you just need to be careful with what you're doing.